Accommodating resistance. What is it? You ever heard of it? You may have heard of band and chain training. Dr. Mill with a little video here on just some what goes on when and why accommodating resistance using bands and chains hanging off a barbell, usually the squat, sometimes with a deadlift and bench press, but most often used with the squat, I would say. What benefit is there in using a band or chain attached to the barbell? This is a little video just to give you a little backdrop of what is going on that may be beneficial when using accommodating resistance. Now, this tracing I'll talk about here in a minute, it has a lot of problems with it in the sense of it was just me on the force plate messing around. The loads weren't necessarily perfectly equal, just because the chain doesn't move in small increments like iron load does. I could have went the other way, of course, right? But I just put some weight on the bar of that. I thought I could do a couple chains on each side, so threw that on there. The effort I put out for each rep was hypothetically the same each time. Of course, I believe in chain training, so maybe there was a bias that I didn't even realize. So all these things, I just want to recognize that. What I'm hoping is that even this messy output here, you can at least get the idea of what's happening if you're interested in why do people do this chain training. Chain training probably became popular in the last 20 years. It's been around. Accommodating resistance has been around a long time. Louis Simmons made it popular. Westside Barbell. At least that's the first time I heard of it. Maybe that wasn't the first time you heard of it, but that's as far back as I can remember. That's the first guy that started using these idea chains. And there's different places to set the chains. There's different ways to set the chains. I didn't really get into that in this video. I had the chain about positioned about halfway through my range of motion. So again, we could argue over where to put it, and probably should be a little lower, and how I clustered it. I didn't cluster the chain. It was more of a continual, uncurling of the chain versus, it kind of hits you at once in a certain range of motion. Again, those are different. We can talk about that later if you want to. But what I just want to talk about this concept. So what you're looking at here is a force tracing. So I have a force plate that's a teaching force plate. So it's not a commercial force plate. I sampled in 250 milliseconds, which is usually really slow compared to 100 milliseconds. It dumps the computer though when I try to do that here. So it's fast enough to at least capture what I'm getting at with this video. The y-axis here is newtons of force, and the x-axis is time in seconds. Okay, so each one of these, and this looks like a bunch of what is going on? This red line was with the iron weight, and the green line was with the chains. What you're looking at is these little troughs here are reps. So this is when I was descending in the back squat, and this is when I transferred from descending, into ascending, and then some noise here, some wobble around, doing whatever I'm doing, and then same thing. Here's another rep, okay, and then this is the peak force coming up each time. The red one is with the chain, or the green one was with the chain. The red one was with the iron load, okay. The green one was with the chain load, all right. And so again, descending, transition, ascending, peak force, and then wobbling around, doing whatever, hitting another rep, descending, ascending, wobble around, hit another rep. And the red one, with the iron weight, so in other words, load is the same throughout. Now, the idea with accommodating resistance is if this is a barbell up here, and this is this back, thigh, shin, and foot, the force of the barbell is consistent, right? It's not going to change when it's just iron weight. So as the further I move these joints away from this line of force from the barbell, the more internal torque I have to generate. In this case, the quadricep muscles, if we just kind of just said one muscle involved, which it isn't, but quadricep, and then over here are glutes, right? These muscles have to work harder and harder. So if this person descends, this hip is going to get further and further away. The muscle's also getting stretched, which makes it weaker. And the same thing here. The knee might move forward more and more, and it's going to stretch and get weaker. So this is like a low bar back squat. The knees hypothetically are in line with this line of force, and the hips are back even further, less the bar is low on the back, and the hips work more. So a low bar back squat should be more glute active squat than a high bar. High bar incorporates both, though. High bar uses depth, though, to really get more glute activation. So it seems like when we cross parallel, we get more glute activation. That's a video for another time. Okay, so what does a chain do? When we get to the bottom here, if the chain's hanging on the bar, and depending on where it's positioned, it doesn't matter. When we get to a full squat, there's more chain on the floor, right, than when we're standing up. And so basically the bar is lower at the bottom. It's accommodating you. Okay, it's accommodating a mechanical disadvantage that you have when you're at the bottom of the squat. And so the bar is lighter at the bottom than it is at the top. Okay, so hypothetically you could load more on the bar than you can actually do with the barbell or with the iron weight. And so at the bottom, though, it equals 80% of your 1RM. At the top, it could be over your 1RM, hypothetically, okay? You can do this in a variety of different ways. You could keep everything sub-maximal and really working on barbell velocity, right? There's a lot of things to do. So does this actually do anything? Or can we see it? And when people talk about strength curves, what are we talking about? So the things I want to really point out here is we could point out a lot of things, but two main things. Number one is that you notice that when I come down and back up again, the width, now I didn't measure these, I could have, the width though in these troughs, now it looks minimal here, right? And remember, this is in seconds down here. These are a little bit narrower, okay? And these, with the iron weight, these troughs here, right, descending, transition, ascending, are a little bit wider, okay? Now, this one is pretty close, right? Well, why would there be any sort of difference between these two reps, one with chain with that? Well, if I'm at the bottom of that rep, okay, and the weight is lighter, I should be able to turn that weight around at a much greater rate of force development than when the load is static, right? At the bottom, I'm at a mechanical disadvantage now. It's going to take me a little bit longer in that transition to turn that weight around. And hypothetically, my rate of force development then, or not hypothetically, looking at these curves, my rate of force development isn't as steep. And rate of force development is just a slope of this line, okay? Now, this is all eyeballing stuff, of course, all right? And I don't intend this video to be anything more than that, okay? We're just eyeballing things. But I just highlighting what, if this was done well, if this was clean with a bunch of people at a proper sampling rate, right, and so on, we would start to see a trend likely that's going to occur. So there's that time, or there's that the length of time between the transition. So it makes sense, right? At the bottom, if the bar is lighter, if you just take a barbell and go, descend and ascend with it, of course you're going to turn it around faster than you do your 1RM, okay? And so the total time it takes to turn that rep around is faster. The main one here, though, I want to point out, especially for strength conditioning in particular, in general, but in strength conditioning, is this peak force, okay? Notice the peak force here. This is at the finish of the rep. So I'm coming up out of the bottom of the rep, and I'm coming up, I'm driving through the load, okay? I'm rising. My joints are coming back under alignment of the force from the barbell, and so I'm gaining a mechanical advantage. When I do this with iron weight, okay, especially when it's submaximal, you can try to drive all the way through that weight, but two things are going to happen at the top if you do. One, the barbell's going to leave your shoulders, or two, you're going to jump, okay? And both of those things may not be a good idea if you have a barbell on your back. So you're going to decelerate the barbell. You're going to slow it down at the top. It's just something naturally that's going to occur, right? And so you can drive through the sticking point, you can drive through these, but as you get to the top, you're going to have to slow down. Well, the chain, because the chain is coming on, okay, and this doesn't even do a good job of really showing the potential of the chain. The chain is even heavier than than your, if it's 90% in iron load and 100% at the top with the chain load, okay, it's going to allow you to push through that chain or drive through the chain all the way through without decelerating, okay, and that's one of the benefits. One of the many benefits, in my opinion, of chain training is that it allows for greater peak forces at the finish because you don't have to decelerate the bar. All right. It could be argued, well, why don't you just put more weight on the bar? Well, because then at the bottom, yes, if you put more weight on the bar, you can accelerate through. But now I have the problem at the bottom where I'm dealing with a static load and I'm going to not be as forceful. A rate of force development wise, I'm going to be very forceful. A rate of force development wise, it's going to be lower at the bottom. So I'm not going to come off with that same rate, even though the force might be higher. And so if we're trying to produce faster movement and more powerful movement, rate of force development is very important, the slope of this line, and then the peak force that's derived at the end is also very important, that the athlete could drive all the way through the rep, okay, without feeling like they had to slow down at the top. The rate of force development is greater. This line is steeper, okay, in its inclination. The slope is steeper. And then until you can look at these and these are smudgy, right? We need a better sample rate here. But not only is the curve wider, appears to be, especially these two reps, but again, we'd have to get more of a sample throughout a bunch of reps. But there's the time that in transition itself. So the isometric portion of the lift, when you get to the bottom and I'm getting the barbell moving back up, okay. Now, I didn't try to pause here. I just hit depth and then try to come up as fast as possible, okay? And you can see just eyeballing, especially these 2 reps, and these 2 reps probably affirm my bias more than anything, is that it took me longer, right? And again, we're talking about milliseconds here, but it took me longer to turn the load around than it did at the bottom. Again, the load is heavy at the bottom. The load doesn't care. When it's iron, it's iron. The force is consistent, static throughout the rep. With a chain load, it is, the load changes, all right? You notice a little bit more at the bottom here, a little bit deeper trough too. This could be as a result of just the barbell load not being the same as well. The chain and the barbell not being the same. Okay, software changes if you like. Okay, hopefully that was helpful. Again, this is not perfect. I'm not saying it is. You can critique the heck out of this thing. Agreed. I would critique it right along with you. I'm just trying to show the concept of kind of smoothing out these strength curves. Okay, that's the idea of there's this consistent. It's more consistent. It brings in the parameters, right, and brings the excessive movement, excessive loads down that might occur with the iron weight. Okay, so in other words, you have a more even application of force with the chain rather than I hit a sticking point and then I get the bar moving it. Oh, then I have to slow it down again. Right? It's more disjointed. This is hypothetically a flat load. Like I'm pushing against the same, I'm applying the same amount of force throughout. At the bottom, I applied a force, and now that I'm gaining mechanical advantage, right, the load's going to push back on me, and so I can provide more force through that as well, right, because the load is giving me more resistance as I go along. And just grab an elastic band and move with it, and you get the same idea of accommodating resistance. When you're weak, the band is weak. When you're strong, the band is strong. And that is complementing our body's mechanical advantage. Okay. All right. If you have any questions, let me know. Shoot me a message if you want to. Like this video. If I just confused you further, you have my sincere apologies. We could talk more about this and this idea of smoothing the strength curve, but again, I hope this video was helpful in explaining the concept of accommodating resistance, at least somewhat. Subscribe to my channel. Lots of videos on a variety of topics, book reviews, and journal reviews. And I'll see you in the next video.